Hello and welcome to an algebra tutorial learning about single variable inequalities. In this video we're going to talk about interval notation. So inequalities have infinite number of solutions. We can represent inequalities with greater than or less than or greater than or equal to or less than or equal to symbols. There's 4 symbols, but there's a lot of ways to represent inequalities. So if you've been watching my series of videos, we've been talking about multiple solutions. We talked about set notation. We're going to cover set notation and interval notation and just kind of see how they all connect. All right, so let's throw up an inequality and let's see here. So I've got, let's do x is greater than 50. All right, so greater than means, well, my solutions could be 51, 52, 50.005. It's just any number for x just has to be bigger than 50. So in set notation, we would use our little squiggly lines and say, okay, I want to represent all the solutions. There's an infinite number of solutions there. So all the numbers for x such that x is greater than 50. And then I would close that off, and there's a way in set notation. This means the same as that. In interval notation, now interval notation again tells you the same information, just a different way of writing it out. It's a little bit more specific to inequalities. So in interval notation, I have, I want to find my boundary, right? 50 is sort of my marker. I want everything greater than 50. So I'm going to put 50 on the left because that's my boundary marker for the least that it can be. But it gets bigger as far as I want. So 51, 53, 58, it gets bigger and bigger and bigger and actually goes on infinitely. And so I'm going to put a comma and say it's starting at 50, but it's going to get infinitely bigger to the right, everything greater than 50. Now with 50, its x is greater than 50, so 50 is not a solution. So if it's not a solution in interval notation, I put a nice curved line indicating that 50 is my boundary, but the solution does not include 50. And then going off to infinity, I put another curved line indicating, well, that just goes off to infinity. Now it looks sort of like a point, right? An x and a y variable or x and a y coordinate that I can plot. And so it can get confusing for students, so you have to be really careful if you're being asked to do interval notation or thinking about the, as you're working with inequalities and solution sets and ranges of solution sets. Interval notation and writing out this way is not representing a point. It's representing a range of numbers that are possible solutions. So when I see this, this interval notation means the same as this thing in set notation, which means this same thing in equality. All the solutions are numbers greater than 50. All right, let's look at another one here. Let's do all the values for y that are less than -6. Okay. So again, so y, there's an infinite number of solutions. Y is less than -6, it would be -7, -10, -45, -67.8. Just has to be less than -6. So in set notation, I'm going to define it as y such that y is less than -6. For interval notation now, it's going the other way. -6 is my high end boundary. So I'm going to put -6 on the high end. And it's going off to negative infinity. It can get as far negative as I want. So I'm going to put a little negative sign for negative infinity. And now because the solution, it's less than -6, it doesn't include -6, so I'm going to put a curved parentheses there and a curved parentheses there. And that would be representing an interval notation, this set notation, and this inequality. These all three mean the same thing. All right, now let's look at a couple examples with greater than or equal to. So let's do w is greater than or equal to 1.5. All right, in set notation, again, w such that w is greater than or equal to 1.5. But in interval notation, it's going to be slightly different. So 1.5 is my bottom end boundary, so I'm going to put 1.5 on the left. And it gets as greater as far as I want, so I'm going to go up to infinity. This just represents 1.5. but anything as far bigger than 1.5 is all fair game. I put the parentheses for the infinity end of things, but for the 1.5, W is solution is 1.5. 1.5 is greater than or equal to 1.5. So I've got to distinguish it now, indicating that that 1.5 is a solution. So I put a solid straight line bracket instead of a curved bracket. Notice the distinction there. With the 50 and the -6, we put curved because they were not solutions. But with the 1.5, I put a square bracket there, or a flat bracket, indicating that it is a solution. So there's my interval notation representing all the possible numbers that work for that inequality. Now finally, let's do z is less than or equal to 0. That can be true, right? So z is basically just any negative number. Notice it also includes 0. It could be equal to 0. So in set notation, I would write that out as this, and 0. And in interval notation, 0 is my high-end boundary, so I can't get greater than 0, so I put 0 on the right. It's my upper boundary. And it includes 0. Z could be equal to 0 in this case, so I put a solid straight line bracket there. But any number smaller than 0, less than 0 is included. And there you go. We got 4 inequalities, hitting all 4 types of inequalities, represented them all in set notation, and showed the same information, the same range of numbers that work in interval notation as well. So you need to be fluent in all 3 forms, and just interpreting what is this telling me, what range of numbers works for this inequality, and just comfortable with them.